In this lesson, we will discuss yet another differentiation skill called implicit differentiation. What is the meaning of differentiation? The process of finding the derivative of a function is called differentiation. Now, implicit differentiation. What is the difference between explicit and implicit? Well, if you look here, y equal to 2x plus 5 is an explicit expression. In other words, y is explicitly defined as a function of x. But suppose I write 2y plus 3x equal to 4. Here, y is not explicitly defined as a function, but it is implied that y is a function of x. Now, to differentiate quantities like this is what we call implicit differentiation. So here is an explicit function, and here y as a function of x is implied. So differentiating this with respect to x is called implicit differentiation. Well, let's recall some of the skills we have already practiced. Now, remember, the derivative of x with respect to x we call dx by dx. The derivative of x with respect to x is dx by dx, and that is 1. But the derivative of y with respect to x is dy by dx. Alright, now tell me, if I want to find the derivative of y squared, what is the derivative of y squared with respect to x? Well, from the last lesson you should know that. Use the power rule. It will be 2y times the derivative of y with respect to x. 2y dy by dx. I know this is a perfect candidate for confusion because you know that derivative of, if I ask you to find the derivative of x squared with respect to x, it will be simply 2x. There will be nothing left. Why? Because we are finding the derivative of x squared with respect to x. If you want to find the derivative of x squared with respect to t, it becomes different. It will be 2x times dx over dt times derivative of x with respect to t. Now, it's very important that you really understand this. Now, let's write some more of these. Now tell me, what is the derivative of, say, p with respect to y? What is derivative of p with respect to y? It will be dp divided by dy. What will be the derivative of p squared with respect to y? Well, the derivative of p squared with respect to y will be 2p times dp by dy. Now, the derivative of m cubed with respect to t will be 3m squared dm over dt. 3m squared times derivative of m with respect to t. But watch this. If you want to find the derivative of m cubed with respect to m, it will be simply 3m squared. Why? Because the derivative of m with respect to m is 1. So, very important to know these simple derivative skills. Okay, now tell me, what is d by dx of y cubed? What is the derivative of y cubed with respect to x? That will be 3y squared dy by dx. Okay, knowing this, let's go and practice what implicit differentiation is. Can you give me a known function which can be categorized as implicit? What is the equation of a circle? How about this equation? X squared plus y squared equal to 4. What does that represent? It actually represents a circle of radius 2. Is that right? X squared plus y squared equal to 4 represents a circle of radius 2. Now, this is an implicit function. Y as a function of x is implied there. Can you solve this equation for y? That's not difficult, is it? Well, let's solve this function for y. If x squared plus y squared equal to 4, we have y squared equal to 4 minus x squared. And therefore, what is y equal to? Y has two values, is that right? If y squared equal to 4, y can be plus 2 or minus 2. So this will be plus or minus square root of 4 minus x squared. Now, if you take your calculator out and draw the graphs of these two functions. Now, go to your calculator and put y1 equal to square root of 4 minus x squared and y2 equal to negative square root 4 minus x squared, and draw the graph and see what you get. You see, y equal to square root 4 minus x squared will be the top part of the circle, and y equal to negative square root 4 minus x squared will be the bottom part of the circle. That's right. So here there are two functions, y equal to plus or minus square root 4 minus x squared is the explicitly defined function which describe this circle. So you must clearly understand the difference between an implicitly defined function and an explicitly defined function. Alright, let's find the derivative of this quantity with respect to x. Always it is important to look for that independent variable. We are finding the derivative of this quantity with respect to x. X squared times y squared. First of all, it is the product. Use the product rule. How does the product rule work? First function times the derivative of the second function plus the second function times the derivative of the first function. So, let's do that. That will be first function times derivative of d bar dx of y squared plus y squared times d bar dx of x squared. And that will be x squared times, what is the derivative of y squared with respect to x? That will be 2y dy by dx. That's right. 2y times the derivative of y with respect to x. So x squared times 2y dy by dx plus y squared times derivative of x squared with respect to x will be 2x, because dx by dx will be 1. Y squared times 2x. So that will be 2x squared y dy by dx plus 2xy squared. Now, this is the derivative of this quantity x squared y squared with respect to x. And we will use this concept as we go on in this lesson. we are now going to see how we can find the derivatives of implicitly defined functions with respect to x. And I want you to follow few simple steps for that. What is the first step? The first step is write down the derivative of each term with respect to x. Just what we were practicing before. And then collect the terms containing dy by dx on the left side and all the other terms on the right side of the equation. And then solve for dy by dx. Now, this is the simplest way to find the derivative of a given function, implicitly defined function with respect to x. Once again, write down the derivative of each term. And then collect all the terms that contain dy by dx on the left side and keep everything else on the right side and solve for dy by dx. All right, let's practice that. Find dy by dx of x squared minus y squared equal to 16 using implicit differentiation. So this is the quantity, the implicitly defined function. What do? We find the derivative of each term with respect to x. That's what we want to with respect to x. And then collect the terms containing dy by dx on the left. It doesn't matter, you can collect it on the right if you want. And then solve for dy by dx. All right, first step, find the derivative of each term with respect to x. D by dx of x squared, right, minus d by dx of y squared will be equal to d by dx of 16. We find the derivative of each term with respect to x. All right, what is d by dx of x squared? That will be 2x. And d by dx of y squared will be 2y dy by dx. Don't confuse between these two. When the independent variable is x, the derivative of x squared with respect to x is 2x. The derivative of y squared with respect to x is 2y dy by dx. So, and the derivative of a constant is 0. Okay, so we now need to solve for dy by dx. We leave the term containing dy by dx on the left side and take the other to the other side. And you notice it will be negative 2y dy by dx equal to negative 2x. And the negatives will cancel, and this is what you get. And therefore, what is dy by dx? Dy by dx equal to 2x divided by 2y, which is x over y. So the derivative of this implicitly defined function with respect to x is x over y. Another one. Find dy by dx of x squared y plus y squared x equal to 10 at the point 1, 2.7. Well, there are two things you notice there. First of all, each term is a product, x squared y. That means you need to use the product rule there. What is the product rule once again? First function times the derivative of the second function plus the second function times the derivative of the first function. Okay, let's do that. In the first step, we find the derivative of each term with respect to x. Why? Because we want dy by dx. That will be d by dx of x squared y plus d by dx of y squared x equal to d by dx of 10. All right, try and do this on your own. You can actually stop the video now and try this on your own. Derivative of x squared y with respect to x will be x squared times the derivative of y with respect to x. What is the derivative of y with respect to x? Is dy by dx. So that will be x squared times derivative of y with respect to x plus y times the derivative of x squared with respect to x. We finished with the first term. Plus derivative of y squared x. That is first function times the derivative of the second. Y squared times d by dx of x, right? Plus second function times the derivative of the second, of the first. X times d by dx of y squared. And of course the derivative of the constant is 0. Okay, let's work out this derivative. That will be x squared times, do that in your mind first. X squared times derivative of y with respect to x is dy by dx. So this will be simply replaced by dy by dx. Derivative of x squared with respect to x is 2x. So this will be replaced by 2x. And here, y squared times d by dx of x. What is d by dx of x? Derivative of x with respect to x is 1. And finally, d by dx of y squared. What is derivative of y squared with respect to x? It is 2y dy by dx. Alright, let's replace all those in here. That will be x squared times dy by dx plus y times derivative of x squared is 2x plus y squared times 1 derivative of x plus x times derivative of y squared is 2y dy by dx. And you notice that there are two terms containing dy by dx. So we will leave those on the left hand side and take everything else on the right hand side. Well, I just cleaned it up a bit, which is x squared dy by dx plus 2xy plus y squared plus 2xy dy by dx equal to 0. Alright, now we leave these two terms containing dy by dx on the left side and take the others on the right side. I hope that algebra is rather simple for you. And now we need to solve for dy by dx. That means first factor out the dy by dx. dy by dx is common in these two terms. So factor it out first. That will be dy by dx times x squared plus 2xy equal to negative 2xy minus y squared. Alright, what do we need? We need to solve for dy by dx. So dy by dx equal to the right hand side divided by this quantity. And we can now find the value of dy by dx at the given point. What is the given point? The given point is x equal to 1, y equal to 2.7. So what all we need to do is replace your x by 1 and y by 2.7 and make sure that this is all done correctly. You've got to check all these values and see whether you get this. It's negative 1.98. dy by dx of the given function at x equal to 1, y equal to 2.7 is negative 1.98. And what is the significance of this? What does it actually mean? It means if you draw a graph of the given function, negative 1.98 will be the slope of the tangent line drawn at this point. Now I have drawn the graph of the given function. Now how do you draw the graph? First of all, you need to solve for y from there in order to put it in your calculator. I used the TI-89 and it even gives you the equation of the tangent line. And you can see y equal to negative 1.98 plus, you can see that is the slope of the tangent line which we got. Alright, try and do this graph on your own, on your calculator. Solve for y from the given equation and use that to draw the graph. Alright, let's try another one. Find the slope of the tangent line to the graph of square root xy equal to x minus 2y at the point 2.5. Well, here again we have an implicitly defined function. So what do? We find the derivative of each term with respect to x. And remember, we have square root of a product on the left side. So we're going to use the chain rule there. Alright, so d by dx of square root xy equal to d by dx of x minus d by dx of 2y. Can you stop the video and write down what this will be? Square root of xy, find the derivative of square root of xy with respect to x. You must understand that the derivative of a square root quantity, here what is the quantity? Xy. The derivative of a square root quantity is 1 over 2 square root of that quantity times derivative of that quantity. Alright, can you do that? Let me write down that for you. It should go something like this. Now I'm going to do derivative of d by dx of square root xy. Remember, derivative of a square root quantity is 1 over 2 square root of the quantity times derivative of that quantity, d by dx of xy. Practice this. Derivative of square root xy is 1 over 2 square root xy times derivative of xy. Okay, and that will be, let's try one more time, will be 1 over 2 square root xy times derivative of xy, x times y, will be the first function times the derivative of the second function. Derivative of y with respect to x is dy by dx plus the second function times derivative of the first function. Derivative of x with respect to x is 1. Alright, did you get this? Okay, let's move on. Always try and do some of these on your own. So, we have 1 over 2 square root y. The derivative of this will be 1 over 2 square root xy times derivative of xy. Now, instead of dy by dx, I have used y prime. Y prime stands for dy by dx. Will be x times derivative of y plus y times derivative of x is 1, so that will be y, equal to 1 minus derivative of x is 1 minus 2y prime. I hope that is clear. Alright, what do we need to do? We need to actually combine terms in y prime because we are looking for y prime. We're looking for dy by dx. So we first distribute on the left side. That will be xy prime divided by 2 over square root xy. This multiplied by this. Plus this multiplied by this will give you this. Equal to 1 minus 2y prime. And there are two terms that contains y prime. We need to keep them on the left side and the others on the right side. So take the negative 2y prime to the left and take this term to the right. Well, what does it become? It will be xy prime over 2 square root xy, that is this term. When this comes to the left, becomes plus 2y prime equal to 1 minus y over 2 square root xy. What do you think is the next step that you will do? Because we would need to solve for y prime, factor out that y prime. So we factor out the y prime from here. That will be y prime times, when y prime comes out, what is left is x over 2 square root xy plus 2. That is the left hand side. And the right hand side remain the same. Now, you need to solve for y prime, means divide both sides by this quantity. So what will that be? Y prime will be this quantity divided by that quantity. So y prime will be 1 minus y over 2 square root xy divided by x over 2 square root xy plus 2. Now, do we need to really simplify this? I don't think so. Why? Because we have been asked to find y prime at a given point. You know the x and y values. So all we need to do is replace your x and y with the given values and then simplify. So we need to find y prime at x equal to 2, y equal to 0.5. We replace those. Y is 0.5, x is 2. So replace those values and then simplify this on your own. That's not difficult. And that gives you 0.25. The derivative of the given implicit function at x equal to y equal to 0.5 is 0.25. And you know what the physical significance of that is that right? Alright, let's do another one. Find dy by dx for x to the power of 3, x to the power of 2/3 plus y to the power of 2/3 equal to 5 at the point 8, 1. Can you stop the video and find the derivatives of each of these terms with respect to x? Let's talk about it. Now, you see, a mental exercise in mathematics is very important. Alright, tell me, what is the derivative of x to the power of 2/3 with respect to x? Use the power rule. It will be 2/3 x to the power of 2/3 minus 1. Is that right? 2/3 times x to the power of 2/3 minus 1. What is 2/3 minus 1? 2/3 minus 1 is negative 1/3. So this will be 2/3 x to the power of negative 1/3. X to the power of negative 1/3 is actually 1 over x to the power of 1/3. You see how it is important to keep that running in your mind? Alright, try this. What is the derivative of y to the power of 2/3 with respect to x? Don't confuse that. It will be 2/3 y to the power of 2/3 minus 1, doesn't stop there, times dy by dx, isn't it? Because the derivative of y squared with respect to x is 2y dy by dx. The derivative of y to the power of 2/3 with respect to x is 2 over 3 y to the power of 2/3 minus 1 times dy by dx. Alright, let's write them down now. Oh, okay. I want you to do this on your own, and I gave you the answer. Alright, I'm going to leave it for you to work out on your own. And if you run into trouble, let me know. Alright, let's try it over. Find dy by dx of x cos y equal to 1 at the point 2 pi over 3. All right. First of all, let's find the derivative of each term with respect to x. Right? So d by dx of x cos y equal to d by dx of 1. That is the first step. And how do you find the d by dx of x cos y? It's a product of two things, x and cos y. So the derivative will be x times the derivative of cos y with respect to x. All right, tell me, what is the derivative of cos y with respect to x? It is negative sine y times dy by dx. You see, the derivative of cos x with respect to x is negative sine x. The derivative of cos y with respect to x is negative sine y dy by dx. Very important to know that. So it will be x times d by dx of cos y plus cos y times d by dx of x. We simply apply the power rule there, equal to d by dx of 1. What is our right hand side? D by dx of 1, derivative of 1 with respect to x is 0. Alright. Alright, tell me what is this? D by dx of cos y is negative sine y dy by dx. There you go. So x times negative sine y dy by dx plus cos y times derivative of x with respect to x is 1 equal to 0. And we need to solve for dy by dx. So what do? Take this to the right hand side. There you go. So that will be negative x sine y dy by dx, that is this term, equal to negative cos y. We can now solve for dy by dx. And dy by dx equal to simply divide by x, negative x sine y. Divide both sides by negative x sine y. So dy by dx equal to negative cos y divided by negative x sine y. And what all we need to do is replace your x by 2 and y by pi by 3. Alright, how many of you know the value of cos pi by 3? Cos pi by 3. It must come to you just like this. Cos of 0 is 1. Cos of pi by 6 is root 3 by 2. Root 3 by 2. Cos of pi by 4 is square root 2 over 2. Cos of pi by 3, which is 60 degrees, all right, is 1/2. Cos of pi by 2 is 0. You've got to know these values. So replace your y by pi by 3 and your x by 2. Negative divided by negative will be 1. Or you can even do this way. Cos y divided by sine y is cot y. And then you know what is cot of pi by 3 equal to. So the derivative at x equal to 2, y equal to pi by 3 is cot of pi by 3 divided by 2. What is cot pi by 3? Well, it's actually cos pi by 3 divided by sine pi by 3. I just gave you the value for cos pi by 3. Cos pi by 3 is 1/2. And sine pi by 3 is root 3 over 2. So that will be this, is that right? Root 3 over 3 divided by 2, and that will be root 3 over 6. Check this on your own and see if this is right. Okay. Now here I have drawn the graph of that function and you got dy by dx at that point. You can calculate that on your calculator. You can see I calculated dy by dx at the given point, x equal to 2, y equal to pi by 3, and it gave me 0.28867, and it is right. Cot of pi by 3 is root 3 over 3. Divided by 2 is root 3 over 6. Okay, let's try another one. Looks a pretty long one, is that right? Find the points at which the graph of the equation 4x squared plus y squared minus 8x plus 4y plus 4 equal to 0 has a vertical or horizontal tangent line. Well, now, you see, this equation is most likely in the form of an ellipse. And you can have vertical tangent lines and horizontal tangent lines. Is that right? Well, a horizontal tangent line is characterized by what? Its slope equal to 0. And a vertical tangent line is characterized by what? Its slope is undefined. Well, you see, how to deal with these? Suppose we get the slope expression dy by dx, say, equal to 2x plus 1 over x minus y. Now, how do we use this to obtain this information? Now, we want to find the point at which the graph has a horizontal tangent line. Horizontal tangent line occurs where dy by dx equal to 0, and an expression like this, a rational expression, becomes 0 when the numerator equal to 0, isn't it? So we set the numerator equal to 0 and solve for x. And then you can find the point where the horizontal tangent line exists. And how do you deal with the vertical tangent line? A vertical tangent line is characterized by the fact that its slope is undefined. When will a rational expression become undefined? A rational expression becomes undefined when its denominator is 0. Is that right? That's right. Anything divided by 0 is undefined. So, in order to find the points of vertical tangency, we take the denominator, set it equal to 0, and solve. That's the procedure. All right, let's continue. So we would say at a point where the tangent line is horizontal, the derivative dy by dx equal to 0. And at a point where it is vertical, the tangent line is vertical, dy by dx is undefined. And as I said, in this case, the numerator will be 0, and in this case, the denominator will be 0. Now, so first we take this quantity and find dy by dx using the 3 steps that we developed already. What are the 3 steps? Find dy by dx of each of the term. Then collect the terms containing dy by dx on the left and the other terms on the right. Then solve for dy by dx. Very simple. Let's do that. Can you, in your mind, do the derivatives of each term? And these are simple terms. What is the derivative of 4x squared with respect to x? That's simple. That's 8x. The derivative of 4x squared with respect to x is 8x. What is the derivative of y squared with respect to x? It's 2y dy by dx. What is the derivative of minus 8x with respect to x? It's minus 8. And what is the derivative of 4y with respect to x? It's 4 dy by dx. All right, let's write them down. So derivative of 4x squared with respect to x plus derivative of y squared with respect to x minus derivative of 8x with respect to x plus derivative of 4y with respect to x plus derivative of 4 with respect to x equal to derivative of 0 with respect to x. What is derivative of 0? The rate of change of 0 is 0. All right? We now know all of these. Derivative of 4x squared with respect to x is 8x. Derivative of y squared with respect to x is 2y dy by dx minus derivative of 8x with respect to x is 8 plus derivative of 4y with respect to x is 4 dy by dx plus derivative of 4 is 0 equal to 0. And now we leave these two terms containing dy by dx on the left and move everything else to the right. So we have 2 dy by dx plus 4 dy by dx equal to negative 8 will go to become positive 8. Positive 8x goes to the right, become negative 8x. Now, what's the next step? Factor out dy by dx. That will be dy by dx times 2y plus 4 equal to 8 minus 8x. And therefore, dy by dx equal to 8 minus 8x divided by 2y plus 4. And can you deal with this now? Can you find the points where you have a horizontal tangent line from here? For a horizontal tangent line, dy by dx will be 0. That means the numerator of the expression will be 0. So put this equal to 0 and find the value of x. But x is not enough. We need x and y. That means once you get the value of x, take it over to the equation and find the corresponding value or values of y. You can see because there is a y squared term there, for each x there will be 2 y values. That's right. Similarly, to find the points of vertical tangency, we set the denominator equal to 0. Why? Because for a vertical tangent, the slope is undefined. Set the denominator equal to 0, solve for y, and then take the value of y to the expression to find the value of x. Again, because there is x squared, for each y value, there will be 2 x values. All right, let's do that. So, for a horizontal tangent line, dy by dx equal to 0, and a rational expression is 0 when its numerator is 0. So we say 8 minus 8x equal to 0, and that gives you x equal to 1. And now we take x equal to 1 to our original expression, is this one. 4x squared plus y squared minus 8x plus 4y plus 4 equal to 0. Put x equal to 1 in here and then solve for y. So I have replaced all x by 1, and can you now rewrite this equation? It'll be a quadratic. You get y squared plus 4y equal to 0. And solve for y from there. You can factor out a y. That will be y times y plus 4 equal to 0. Tell me, what are the values of y that will make the left-hand side 0? One value is y equal to 0. The other value is y equal to negative 4. So one value of y is y equal to 0. The other is y equal to negative 4. So tell me, what are the points of horizontal tangency? horizontal tangency occurs at x equal 1 and at these two y values. That means 1, 0 is a point of horizontal tangency, and 1, negative 4 is another point of horizontal tangency. So we have 1, 0 and 1, negative 4 are 2 points. That means there are 2 horizontal tangents and they occur at these 2 points. How about vertical tangents? The vertical tangency occurs when dy by dx is undefined, and that happens when the denominator is 0. And so we take 2y plus 4 and set it equal to 0, and that gives you y equal to negative 2. And take this y equal to negative 2 in our original expression, replace each y by negative 2, and then solve for x. Let's do that. I replaced each y by negative 2 and then rewrite the equation. It will give you 4x squared minus 8x equal to 0. I'm going to leave it for you to check this to make sure you get that equation. You see, in a class like this, you don't just watch to learn. You've got to actively be part of it. In other words, you've got to do these steps to make sure that you get it. All right, how do we solve it again? You can factor out a 4x, is that right? So that will be 4x times x minus 2 equal to 0. And what are the values of x that will make the left-hand side 0? One is x equal to 0. The other is x equal to 2. So x equal to 0 is 1, and x equal to 2 is the other. And therefore, what are the points of vertical tangency? The first point is x equal to 0, y equal to negative 2. The other is x equal to 2, y equal to negative 2. So the points of vertical tangency are 0, negative 2, and 2, negative 2. And how does the graph of this look like? Now let's draw the graph of this. That is the graph of that given expression. Now how did I draw that graph? Can you do that on your calculator? Yes, you can. But all you need to do is solve this equation for y. It takes a little skill to do that. And then enter it in your calculator, the positive function as y1, negative function as y2, and you will get this. Now look at this. The horizontal tangent line at 1, 0, that's 1, 0. A horizontal tangent line at 1, negative 4. There you go. That's 1, 0. And this is 1, negative 4. Those are the two horizontal tangent lines. And you have a vertical tangent line at 0, negative 2. That's one vertical tangent line. And another one at 2, negative 2. So that is one vertical tangent line. One is over there. Isn't that beautiful? So by doing implicit differentiation, we were able to find all the horizontal and vertical tangent lines of this elliptical figure. All right, let's try another one. Find the points at which the graph of the equation 2x squared plus y squared equal to 6 has a vertical or horizontal tangent line. Well, it's not different from the one we did, so let's go through that. I want you to do that on your own, exactly the same way I did. And I give you the answers. The horizontal tangent line occurs at this point, these points, and vertical tangent line occurs at plus or minus square root 3, 0.